Yeah, please proceed.
Yes, sir.
Good evening, one and all present here. I, Kritika Pandey,
And I, Kashish Rawat from India, would like to move on with the technical session 4. I would like to introduce the session chair, Dr. Mais Radhi Al-Ruwaishedi from Al-Balqa Applied University, Jordan, and Dr. GREESHAMA Arya from Indira Gandhi Delhi Technical University for Women, New Delhi, India. Talking about our first session chair, we have Dr. Mais Radhi Al-Ruwaishedi from Al-Balqa Applied University, Jordan. Dr. Mais Radhi holds a PhD in Architecture and Engineering from the National University of Malaysia in 2020 with a distinction majoring in Architectural Design and Building Informatics Modeling, and holds a master's degree from the University of Jordan in 2050 with the distinction excellent grades, and holds a bachelor's degree in architecture from Hashmat University in 2013 with a very good grade. Dr. Myers specializes in architectural design and building information modeling. As an architectural design specialty is a field concerned with the design and planning of buildings and architectural structures and transforming them into reality. This major includes the study and analysis of sites and functional and aesthetic requirements of urban projects and development of design and meet these requirements, where the speciality of building models is used in architectural design to create three-dimensional models for projects using specialized computer programs. This allows architects and clients to see and evaluate the design before proceeding with the actual construction. Building model Building modeling is an important tool in clarifying architectural concepts and communication between teams involved in a project. Her research interests include architectural engineering, architectural design, building information modeling, building technology, smart building, and sustainable architecture. Now, I would like to introduce our next session chair, Dr. GREESHAMA Arya from Indira Gandhi Delhi Technical University for Women, New Delhi, India. Dr. GREESHAMA Arya received the BTech and MTech degrees from Dr. APJ Abdul Kalam University, Lucknow, India, and the PhD degrees in Electronics and Communication Engineering from Uttarakhand Technical University, Dehradun, India. She is currently an associate professor with the Department of Electronics and Communication Engineering, Indira Gandhi Delhi Technical University for Women, Delhi, India. She has more than 17.5 of experience in academics and research. She has published more than 35 research articles in various international journals, including SCI, ESCI, Scopus, and ISI Index. That has also included IEEE international conferences. Her research interests include wireless and sensors networks, wireless communication, network security, and Internet of Things, 5G network technology, artificial intelligence, deep learning, cloud computing, and distributed networks, data information and networks, and big data computing. Now, I would like to invite the respected session chairs for proceeding up with this technical session 4.
Hello everyone. Thank you for the introduction. And I am Dr. Mais Radhi, and I'm honored to serve as the chairman for the technical session 4 of ICWTNS 2024 online conference. I work as an assistant professor in architecture engineering in Al-Balqa Applied University in Jordan. And first and foremost, I want to extend my gratitude to Dr. Ashish and his team for inviting me and for organizing this conference so efficiently. I would like also to extend a warm welcome to my co-host, Dr. GREESHAMA from Indiana Gandhi Delhi Technical University. And I apologize in advance if I mispronounce any names during our session. To ensure that we stick to our schedule, I kindly remind all the presenters that they have 10 minutes for their presentations and additional 5 minutes for audience questions. Then this will help us to keep everything running smoothly and ensure that everyone has a chance to participate fully. Let's make the most of our time together and dive into our fascinating topics that we have lined up for today's session. Thank you all for being here, and let's have a productive and engaging session ahead. Dr. GREESHAMA, do you have anything to add?
No, thank you. Thank you for my introduction, Kashish and Dr. Mais. Can we have our first presentation for today of this session?
Yes, maybe we have the first paper with the ID ICWTNS 2024 221 with the title of Optimized Deep Learning Model to Predict Business Bankruptcy. by the author Dino, Quinteros, Navarro, and Ciro Rodriguez.
Hello, sí.
Hello.
Hello, good evening. My name is Dino Quinteros Navarro.
Maybe we can start the presentation with you if you can share
Okay.
your screen.
Yes. Okay. Hello, I am Dino Quinteros. I'm going to present the article in the conference. I can start now. Yes. Okay. Fine. Its name, the article, optimizing deep learning model to predict business bankruptcy. The authors, Dino Quinteros Navarro, Ciro Rodriguez, la University National Mayor de San Marcos, de Perú. Uh, this article studies the ideal and optimization path prediction accompanied the bankruptcy according to internal and external environment. Uh, okay. For this reason, the optimization under this model is consideration a specialized process that allows the precise identification of the factors that lead to the bankruptcy of companies and the identification of the necessary correlation between relevant variables. Companies have problems in the credit evaluation, which causes high interest rates and the distortion the nature of financing. Most are in the subsistence stage, accessing financing and opening the other market generated subsistence activities. Uh, Potential bankruptcy. No? Compañías have accurate and critical targeting activities due to inconsistent data and misinformation on financial aspects. Okay. A proposal performance es fundamental en un control system. Y ARYA measuring compañías financial aspectos before and after obtaining a loan is essential. The rating of financial performance originated the profitability of a company and is a long-term continuum. Este model presenting, este artículo presenta un optimization machine learning model to determinar compañías bankruptcy where, various bankruptcy modelos are recurring with relevant indication according to the industry and institutional segment. Methodology. The exploratory data analysis methods was used and was complemented with the model proposition by the author Al-Sheref, which determined three stages: data exploration, model selection, and implementation. Data exploration corresponds to dataset exploration es a medio system compañías en Lima, Perú. In model selection, three models: logistic regression model, random forest model, neural network model. 21 variables were determined to be considered for the model: bankruptcy, capital, letters to pay, access credit satisfaction, and cost effectiveness. In stage 3 implementation, the select model neural network model considers 21 variables that have characteristics specific. Initially, there is a of precision y accuracy. Results: optimization model training. After that training, uh, uh, how we see events that are necessary to improve accuracy. Optimization model results curve rock number the companies that are risk on bankruptcy, percentage of companies that risk bankruptcy, number of companies trust the risk no risk of bankruptcy, percentage of companies that risk and of bankruptcy. Results factor para business bankruptcy, performance payment, factor para business bankruptcy, insolvency factor. Correlation where determine payment performance with capital, profitability, business satisfaction, and insolvency with activity time. A three correlation. The discussion, the logic regression model, considers techniques for direct application in the specialized process, the companies, and the results obteniendo have excess. ¿No? The random forest model requiere specification than general average. No requiere correlaciones between variables in the of context. The neural network models allows the deployment of multiple variables and where they generate correlaciones to result in correlation, ¿no? Of context and definition by the company. The results were considered to be great. 87. The model optimization. The optimized deep learning model considers the select model with complementary techniques such as the identification of relevant variables that are related to the implementation of context, and with this the training of the optimization model is correct. It is the model 97 precision accuracy 97. Conclusion: the application of the optimism model allowed us to identify that 134 companies are under risk of bankruptcy. Out of the total 379 employees. The most determined variables for business bankruptcy in the context of the company under study: payment performance, capital, profitability, activity time, business satisfaction, and insolvency. The model studied logistics regression, random forest, and neural network have limitations in the terms of identifying specific and relevant variables according to the context of the company. Relevant correlations were identified: payment performance with capital, profitability, business satisfaction, and insolvency on activity time. Thank you.
Thank you for the presentation. Is there any query from audience side? Okay, I got a query, sir. Can you please explain me how the uncertainties can be handled by this model, which can be caused by that economic conditions that may lead to bankruptcy of a company or any system?
Uh, the explorative data analysis method uh, identification 21 variables were determined considerar para el modelo. Eh, 21, 31 variables, ¿no?
Okay. Okay, so anyone else want to know anything? Any other query?
I just want to thank him for the presentation and the precise conclusion that he presented for us. Thank you for you.
Thank you. Yeah, can we have the next presentation? Who's available? I guess that paper ID 241. Is the presenter available with us?
I think it is 223.
Yeah, it is there, but I guess the presenter, none of the author is available in that, the list. Yeah, it is there.
Paulo Santos and Roberto
Hi,
Santos.
hi, I'm here.
Yes, and your paper title is Creative as a Cooperative Factors for Increasing the Gross Domestic Products in Alba-America by Paulo Santos and Roberto Santos and Ciro Rodriguez. If you are present, could you please, you are requested to start your presentation?
Okay, thank you. You can see my screen
Yes.
and you hear me?
Yes, yes.
Nice. Thank you. I'm going to start. The paper is called Creative as a Cooperative Factor for Increasing the Gross Domestic Product in Ibero-America. The authors are Paula Santos, who's speaking right now, the Dr. Roberto Santos, and the Dr. Ciro Rodriguez. Well, we're going to start with the methods and materials. The new concept, Innovation Index, in Ibero-America examines the levels of invention coefficient. Both are dimensions, as we can see in the square of your right hand. Both innovation index and invention coefficient are both dimensions of the creative factors. Then we also examines the three dimensions of the cooperation factors that are economy, bibliography, and human resource in research, development, and innovation. And that all examines in 31 countries of Ibero-America. The dataset is of the Science and Technology Indicators Network between 2009 and 2018. In both squares, we can see the relationship of the creative factors and the cooperation factors, and the variable or the dimension that link both squares are the innovation index. So right now we're going to continue with the innovation index. And in the first equation, we can see the variables of the first equation, the variables that involves the innovation index, and all these variables have a relationship with the economy, scientific bibliography, and the human resource of RD&I. With the analysis of the model 1, we can see that the variables of the cooperation factors, the three dimensions, are the same or have a strong relationship with the innovation index with a R square of 0.99. We can see the histogram and the normal regression of the innovation index. And we also can note that the cooperation factors and the innovation index have a strong relationship again. Now we going to see the relationship between the innovation coefficient and the innovation index, and the invention coefficient. Both are the dimensions of the creative factors. Well, this relationship is strong with a square of 0.95, and we also can explain that the lowering of the innovation index, raises the likelihood that IC or the invention coefficient decrease. So if the innovation index decrease, the invention coefficient also decrease. Until here, we note that there is a strong relationship between the three dimensions of the cooperation factors and the innovation index. And also, we note the strong relationship of the innovation index with the invention coefficient. So now we're going to understand the relationship between the factors, the cooperation factors and the creative factors. Well, we're going to see the strong relationship of the GDP per capita and the three dimensions of the cooperation factors. In the economy dimension, for each dollar spending on science and technology per habitant, the GDP per capita increased in $35 with a square of 0.83. In the dimension of bibliography, for each Scopus publication per 1,000 inhabitants, 1,000 inhabitants, the GDP per capita increased in $146 with a square of 0.72. In respect of the dimension of human resource in RD&I, for each full-time researcher, for every 1,000 people in the economically active population, the GDP per capita increased in $3,504 with a square of 0.76. So we can note that the three dimensions of the cooperation factors can stretch the GDP per capita of the countries, of the 31 countries in Ibero-America. And these three dimensions have a strong relationship with the invention coefficient. With the innovation index. So we can use the innovation index to calculate how it stretches the GDP of these countries. And now we're going to see the variation of the innovation index throughout 10 years of study in these 31 countries of Ibero-America. In the map, we can see the color green and the color pink. In the color green are all these countries that have stretched the innovation index through these 10 years. Between the 2009 to the 2018, the 6 countries that have most increased in these 10 years are Ecuador, Panama, Portugal, Uruguay, Colombia, and Chile. And on the other hand, we have the pink color in the map, and we can see that Puerto Rico and Argentina are both the countries that have reduced in the most this creativity or innovation index in these 10 years. But if we pay attention, also can see that are more countries that have increased their creativity than reducing their creativity. And so, in this way, we can understand that use the innovation index is a measurement tool to become possible to assess the creativity of the both factors, the creative and cooperative aspect in Ibero-America. And we can understand also that there is a strong relationship between the invention coefficient with the innovation index. Um, well, then we can understand also the importance of investment in the human resource and in RD&I to generate more scientific publications and to enhance the creativity and the cooperative fight in science in Ibero-America, in the 31 countries of Ibero-America, for the positive way the socioeconomic well-being to impact in these countries. We also see that in the Iberian Peninsula has increased its creative capacity, but the Caribbean has seen a reduction in this creative capacity. And so we need to understand that through the innovation index, we can stretch the GDP of these countries, and also we can stretch the economy, the scientific bibliography, and also the human resource and RD&I. So this paper also proposed to promote the public policies centered around investment in science and technology, in the scientific dimensions in index journals, and the full-time employment of qualified personnel for research. And in this way, this paper wants to increase the creative, promote the increase of creative capacity and socioeconomic well-being in the countries of the region. In this way, we can invest more in the human resource for RD&I. As conclusions, we have seen the relationship, the strong relationship between the three dimensions of the cooperative factors with the GDP per capita of the countries, and with these three dimensions also see the link of the cooperative factors with the creative factors because of the relationship of these three dimensions with the innovation index. And also we can see the strong relationship between the innovation index with the IC. So in this way, we also can understand the strong tool that is the innovation index. So we, in this paper promotes the investment in science and technology for these countries to even raise more the creative factors, the innovation index, and the IC. So with investment in scientific and technology also opens the doors to an improvement in the GDP of the countries, promotes the strength of the GDP of the countries, and also promotes the socio-economic well-being for the countries. So the development of science and technology emerged in the 31 countries of Ibero-America, but also this paper promotes the public policies to investment more in the science and technology, in the researchers, the economically active people who are researchers to these countries for these countries to increase the scientific publications and for the strength of their GDP. So that's all. Thank you.
Okay, thank you for the presentation, Paula. It was a really interesting topic. Through your presentation, only I could understand that things are going in that part of America, Ibero-America. So, is there any query from audience side? Okay, no query. Thank you for the presentation. So, the next presentation is for paper ID 225. Do we have the presenter with us? For paper ID 225, do we have the presenter with us?
Their name is Alexander Alva and Ciro Rodriguez and Dick DeLego. Are you available now?
Think it's not ready, please. Can you go to the next?
Okay, all right, sir. So the next presentation is for paper ID 241. And the people with this paper is José Antonio, Ciro Rodriguez, and Victor Hugo. We have the presenter with us. For this paper ID 241.
Yes, it's present. José Ogosi.
Okay, he's there.
José Ogosi.
Hello everyone. I'm José Augusto.
Yes, sir, you can start presenting.
Okay, I want to present. Please, hello. Okay, can you see my screen?
Yes.
Okay.
We started presenting, it is not coming yet.
Okay, well, please, first, let me introduce myself. My name is José Ogosi from the University San Juan Bautista from Peru. And in this moment, I'm going to present on a project. And this project was designed for my person and another partners. The name is the design of machine learning model for engineering projects through the new CSKT methodology. This is a case of the pension system in Peru. Well, the authors is José Ogosi Auqui, that's my person, and my partners is my Ciro Rodriguez Rodriguez and Victor Hugo Guadalupe. They are my partners. Well, first of all, recruiting people often creates complication either due to the criteria established by companies based on their specific requirements, or due to the age-related limitations. So, in this chart, we want to present the theoretical framework. According to the hard.
I'm sorry to interrupt you, but the presentation is not available on screen, right, Dr. GREESHAMA?
Sorry. Sorry. Please. Well, give me a second, please. Give me a second, please. Maybe now it's presenting.
Yes. Yes.
Yeah.
Now it's presented.
So sorry.
Okay, proceed,
That's
please.
my fault.
That's it. Proceed.
Okay, well, so like I say, according to in the personal heart EL2 and 2021, machine learning has a ability not to only to predict the existence of the compound, but also to directly anticipate various observable microscopic characteristics such as hardness, ductility, softness, and curie temperature. According to the also Greener ITA in 2021, the term machine learning broadly encompasses to the process of fitting of predictive models to data and detecting clusters of information within data set. Well, all of this information we can see this all this information, in different, I don't know, documentals, books, also including movies. Well, this is just the framework steps involved in machine learning. Machine learning model training guide for biologists shows a sequence of the machine learning model training works, and this is a chart. For example, we have in here, so sorry because this is in Spanish. Definir tarea, we have defined the task, and also define the task. We have to obtain the data, and we continue with the chart, and we have to select the model, we have to train, we have to and other different concepts that we have to follow. For example, in the case of in this, I don't know if you are seeing my mouse. We have enough data, for example, and we have a conditional no or yes. We have obtained more data, or maybe you have a small number, and different functions or labels or data labels, for example. This is just a chart, and this is the chart that we have to follow to complete to obtain the data and to complete and to obtain more concrete data specifically. Well, this is the machine learning model training diagram. Well, we are studying machine learning, and machine learning is an entire world. And well, for us, within the decision tree are the points of it. In common health, in the health part, there are two options, which are the working time and depending of or independent of retirement. So we proceed to an AFP, sorry, while in the other case we must to select any that two. Well, just this is a conditional. For example, like in programming, we have to a conditional like a for. Like a conditional for example, we have yes or no. That's it. So we are going to apply to this conditional in this training diagram. We have a diagram like I was saying. We have a machine learning. We have all conditions. So we have supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, multitask learning, ensemble learning, neural network, instance-based learning, and things like that. Well, this is the CSKT methodology, and this methodology was developed and checked by my person and by our person and my partner's person too. And this is based in our doctoral study. And well, it means that design of the CSKT methodology sequence diagram of the CSKT methodology that shows us show us each of the phases where the data selection for the machine learning modeling is developed. So we have the processing here. This is all the process. This is the points involved in the development of machine learning. Well, this is a business modeling, exploration, display, and preparation. Well, this is only the points, the most important points, no, to business understanding. We have to understand the business where we are focusing, and the exploration is data selection, understand the data source, where is the data provide, preparation, and cleaning. Cleaning is clean data, clean the database, and things like that. And preparation, in this case, we have data understanding, data preparation, and take a sample from. And display, well, we have a submit model version. That's the most important. Well, we have another model. We are showing CSKT and the business model preparation, exploration, and visualization. That's how it works, everything. And in this part, we have data acquisition, ATL, model training, data testing, and also optimization. Well, are you showing the infrastructure showed the user starts with the mobile application interaction where he sends instructions to web service 8 to an application server that is connected to the other backend service and the Firestone service database. In this case, this is a combine of different services, microservices, database, and also routing connections and things like that to optimize all the processes. Well, this is the code, basically the code, how we can validate the code. For example, in this simple code, we have a profile, no? For example, name and last name. We have a nombre y apellido, but in English we'll say, in English it is a name and last name. No? In this case, for example, barba, calcino, marino, marcelino, and edad 20 and sexo masculino, no? Age 20, and we have to sex a male. And this is a rank with jubilars. We have a range. In this case, for example, is 16. And this is a salary, for example. This is a salary to perceive month by month, for example. In this case, this is a number. Well, and this is the aspiración ganar más, no? And this is the projection, for example. In this case, this user is going to receive this kind, this amount in soles in Peru, but the projection is to obtain more than this number. So for this adjustment, we have taken off as reference of the case of Barba, Calcino, Marino, Marcelino, like I said, which has the following information in JSON code. JSON code, it is a code in all the programming system that it is updating information, not only with this guy, it's with all the information that we are consulting day by day. The ROC scheme of the machine learning model being one of the model performance metrics to determine if there was an improvement and the prediction of the present model. Well, yeah, this is just a prediction since when, for example, this guy is taking the example, the before example of Marcelino, we have to take imagine 2020 until nowadays. So this is the ROC. Why? Because this is since that day until that day, the diagram will be increasing because the pension, because the money of this person will be increasing in the future. That is named as a ROC. And the decision tree well, we have where the where force retires, the decision tree is taken as a reference for the case on the return taking as an example, having a reference of how the prediction route as such was. Well, in this case, for example, we have age. In this case, it is in Spanish, edad, tiempo de trabajo, no importa el tiempo de aportaciones para jubilarte, but in English but in English is age. Work time, since the age, the time that this guy was working. No importa el tiempo de aportaciones para jubilarse. Well, this is the projection. Since this age, for example, 2020 until now, or maybe until, I don't know, 30 years. This is a projection. And this is and this projection, it is very important because it takes a decision, a very important decision, because in this country we have, ONP and AFP, ONP and AFP. And that is two models in this country. We have to check and select, but our own decision. What is the most advantage, for example, no? So here in Peru, it is complicated to choose one of these options. So with this model will help us in the future, since now to the future, to choose or what is the better option, or it is ONP or maybe it is AFFP, to acquire maybe an excellent money month by month. So we are retired, this is the functional model design. Well, this is maybe this is the backing how it works, our functional model. It goes from the execution of application to the processes that goes from the import libraries. Like I said, this is the backend, the routes that the model must follow, the execution of the results that the model expressed through the data. Well, like I said again, this is the backend. We in this functional model. This functional model will take the better route to take the better decision for this person, to acquire a better salary, a better money for this time and the future. And here in this country, it doesn't exist models like this, for example, because people every day by day, have to work, have to go to the OMP or maybe to AFP, and that persons makes that people makes queues to request what is the best option and things like that. So in this country, it doesn't exist a better option like this model. So for that reason, we choose that project, and we encode also. Well, this is the process, and this is the technical comments. Based in the cases explained above, the sequence was established. Based on the decisions you made when entering your data. Well, the data is very important because the data is not that similar. Because an user has a data, but the other user has a data also, but it's completely different because they are going to perceive a different kind of salary and money in the future. So that is very important. And this chart shows us the process. For example, this is the feedback, technical feedback. Data SBS completa con información de los usuarios. Well, the SBS, it is how how it was in English. It is an area. It is a part of the government who show us who saves the data of the different users in Peru. So in this part, for example, the data SBS completa con información. Well, here is that SBS, Superintendencia de Banca y Seguros in English. I don't know how I can say in English. Banca superintendencies, I guess. I don't know but this in this case, all the banks, all the Peruvians, the government has all the information of each person in each Peruvian person. So after that, limpieza de data de SBS. Well, after this. After this part, in this process, we have to clean the data. We have to validate if this person exists, it doesn't exist. Maybe this person died. Maybe this person it was invented. I don't know, things like that. And after that, we have to create a JSON structure. And in program JSON structure, it is a part. It is a very important part where we can consult a different database. In this case, for example, JSON, XML, and maybe creación de estructura XML, like I said, database consulting. And after that, we have to construction de la web service. And after we have this information, we have to construct, or maybe you have to implement a web service. Maybe it could be Amazon Web Service, a Google Web Service, I don't know, different business that provides us a web service. Well, after that, we have a web, we have a training model, and we have a consulting, we have an answer response, and we have maybe here we want to generate a general model and things like that. Well, this is maybe that is the process, and this is the playback instruction. Well, this is application mobile, HTTP. Well, this is the protocols, web server, application server, and Firebase, database, another backend service, like I was saying in the last information. Well, that's it. I hope you enjoyed my exposition, my information. This is a model that we have implementing here in Peru. That's an attendance. And well, thank you very much. See you soon.
Thank you for the presentation. Any query from audience side?
Yeah, Dr. Josh, I have one query. Can you show me your PPT? There is one graph ROC.
Which graph? Sorry.
There is one graph you have mentioned ROC in your PPT.
Which number? Sorry.
Congratulations to you. Your presentation was so good.
Okay, but which presentation?
This presentation just you were giving, there was a slide in which you were mentioning ROC. So it's talking about that graph.
Graph, yes.
So sorry, I can't hear you very well. So.
Muestra los gráficos. Quiere ver un gráfico.
Well, for example, we have this is the backend.
Pon la presentación, no estás presentando.
Can you see my?
No se puede, no. Presenta y te van a explicar cuál gráfico.
Wait. Hold on, please. Hold on. Okay, can you see now?
Yes.
Yeah,
Well, yeah. Tell me what. Which
Just
graph?
move ahead. Yes, move ahead.
Okay.
Just move ahead. Yes.
Okay.
Yes, this one. Just wait. Previous one. Yeah, this one.
Yeah.
So my
Okay.
query is, you have two lines. One is straight, linear, and the one is moving. You can say drastically it is increasing. Then it is
Okay.
just meeting with the linear one. So what is the difference between these two lines?
Well, well, like I said, uh, each people. This project is focused in each people, each Peruvian people. So the difference is the salary and the time that this person was working in Peru, and like I said, in Peru we have OMP and AFP. It's two difference because OMP belongs to the government and AFP belongs to the private. So the straight line refers to AMP because if I register in OMP, my salary it wasn't increased. It is linear. It is a line. If I gonna perceive, for example, 2,000 soles or $2,000, all my life I'm gonna perceive 2,000 soles. That's it. But in the case of the AFP, maybe my 1,000 soles, it could be, for example, 1,015 soles, for example. So for that reason, it is a projection. It is a reference. It is a it isn't an exact data, for example. For that reason, that is the ROC scheme of the machine learning model being on the model of performance. This is a matrix. The matrix change day by day, person by person.
So it means you are using machine learning model to calculate this thing. Is it?
Yeah, yes, because we can use another, for example, we can use database, but in this case we used a machine learning because we need to predict if it is uh, you know if it is more exact
So
decision.
how much accurate result you are getting in the form of
Well,
percentage?
uh, you know,
Have you checked?
uh,
Yeah.
well, our we used 2,000 and 3,000 person as a model to this o sea, to design this metrics.
No, I am asking about the accuracy of your model.
Sorry, can you repeat, please?
I am asking about the accuracy of your machine learning model. As you are
Well,
giving input and based on that you are getting output. So how much accurate your model?
like I said, well, machine learning for us in this example, for example, it is more exact than another predictions that we are having or we are doing in the past. We are doing with different database with different softwares, for example. But we are implement um, the ROG scheme in this case, no, machine learning to acquire more exact data. So that's the reason.
Okay, sir, no
Wow.
issue. Thank you very much. If
Okay.
Okay. Well,
any other having any query, you can ask.
so sorry. To explain what I wanted to explain, Jose, he's explaining that this ROC curve, it represents
Yes.
the threshold to optimize the behavior of the model. So
Mm-hmm.
this is with a perfect classifier showing the true positive rate and also against the false positive rate. So that's what wanted to mean with the uh, research that he has done about the wage of the persons in the social security.
Yeah.
Oh, okay, sir. Got it now. Thank you very much, sir.
Yeah.
Okay, thank you for the this question answer session. And next presentation is for paper
Thank you very
ID
much.
153. Do we have the presenter with us for paper ID
Yeah,
153?
yeah. Before I want to present of the previous one that we was jump, okay, paper 225, I think so. After I will continue with the next one, okay.
Okay, okay, sir.
Thank you.
Okay, so next presentation is for this paper ID 125. Can we have the presenter with us?
Yes. I will support. Okay.
Okay.
Okay. This was the before presentation of the Alexander Inga. Okay. And so he is not possible to stay. I will explain this paper. Okay. And after I will continue with the 153
Right. Yeah,
paper.
155. Okay.
Okay, thank you. Thank you for your comprehension. Okay. Well, this is a review about the assessing offshore oil spill using remote sensing and geospatial artificial intelligence. Okay. Currently there is a serious damage. Okay, in the environment. So artificial intelligence can cut across all the discipline of human knowledge, with favors the development of new approach to the care and preservation of this environment. So oil spills at the sea is cause many very problems to the all environment. Okay, and it is almost caused by the transportation and marketing of hydrocarbons that has been considered an unstoppable source in the pollution of the century. So this SLR analyzed the most recent publications in the artificial intelligence, considering the machine learning and deep learning models, okay, with the spatial component that is the geospatial artificial intelligence, GeoAI. And it is associated with the remote sensing that allows to find the way to predict and detect oil spills based on the best accuracy rates achieved by computational models. So there are main oil spills in the world. For example, is in the boat Atlantic Express, ABT Summer. Okay, the most recent it was in 2018 in Sanchi in Shanghai, China, with 113,000 tons that was spilled on the sea. Okay, so as we see in the map, it is in different parts of the world. This is a spill, or oil spill is damaging also the environment. So in Peru, in January 15, 2022 year, there was a largest environmental disaster occurred because of the spill of 2,000 barrels of oil spilled on the coast. Okay, so it was operated by the company Repsol and located in the district of Ventanilla and the province of Callao, this close to Lima. So the environmental impact of this ecological tragedy left a balance of more than 11,000 hectares affected, okay, and contaminated sites of natural protected areas. So, searching in the literature about how artificial intelligence can help it involved with detect this oil, okay, that is spilled, and using different technologies. For example, is AR and Geo artificial intelligence. So this was collected all the information, okay, to understand how is occurring and how we can solve this problem. So for do this, some questions were done. For example, how are the factors that allow to identify the occurrence of oil spills at the sea using remote sensing? Or how are the spills detected using geospatial artificial intelligence to mitigate the oil spill pollution? Okay. So the goals of this question was identify the factors that allow the occurrence of oil spills at the sea, remote sensing, and detecting oil spills using geospatial artificial intelligence. So in methodology was used a peacock method to understand, to find what is the population affected, what is the intervention that will solve the problem, and the comparison or remote sensing, and also the results and the context environment. Okay. So in this comparative summary of the main publications in synthetic aperture radar, SAR, or machine learning or deep learning between 2008 to 2023. There was found there are many algorithms like deep learning and convolutional neural networks with YOLO that has a precision of 95%. And just with machine learning and SAR, ERS, and MBSAT, this was a precision of 90%. And using other algorithms that deep learning and UNet also, deep learning with convolutional neural networks, just using the data sets of SAR and UAVSAR. So it was get them the most precision, the 99%. Okay, so we can see that combining many technologies, okay, we can get good results. So in conclusion is that we found that there are several approaches that were established, such the ability of perform regression processes and texturing the characteristics or characterization of Tamura that resembles the sense of human visions and the personalized vision in cloud-based computing platform using Microsoft Azure with the machine learning service. The measurements of the thicknesses of the spectra of different types of oil through the laser-induced fluorescence LIDAR also are good technologies. So the development of an unsupervised isolation forest, okay, also is a method for hyperspectral segmentation images. And so we can conclude that there are some technologies that can be used to solve this problem that damage the environment. Okay, so to determine the oil spills with geospatial artificial intelligence, based on in traditional disciplines such as geographic information system, okay, or remote sensing, It can be using models of machine learning with the precision prediction that reach in the range of 24% to 96%. But using deep learning precision, the prediction reaches a better range between 99 and 99.19%. So it's a better accuracy of identification of this. Okay, thank you.
Okay, thank you for the presentation, sir. Any query from audience side?
Thank you for the presentation. It was a quite interesting topic. Thank you.
Okay, now if you let me, I can continue with the presentation, paper number 153.
Yeah, sir.
Okay, thank you very much. Okay.
Now you will start with the paper of 153.
Yes.
Electromechanical engineering generation by domestic grey water. Yes, go proceed,
Yes.
please.
Okay, I'm ready, please. Well, in this paper, the topic is about the electrochemical energy generation by reusing domestic grey water. As we know, one of the needs in the world is the missing of water. So there are research that can predict that the water in the world will be run out in a few years. Okay, so this is a very important resource that we need to reuse sometimes. And the other resource that is very important is the energy. So in this research that we try to find is how we can take advantage of this domestic grey water and convert it in electrochemical energy. Okay, and so in this study is explored the potential of converting domestic grey water into electrochemical energy. So as a solution amidst growing environmental concerns, is designed a galvanic cell prototype. The research aims to transform the chemical energy in a grey water into electrical energy through redox reactions. The study recognized the need for caution in applying its findings in a larger scale, given the prototype's small scales and the potential impact of varied grey water composition on energy efficiency. So this study contributes to the sustainable energy research by offering a novel approach to wastewater energy recovery, promoting environmental sustainability and efficiency. So to know how it's working this process, we just use the basic concept of a battery, where we have the anode and cathode, and it's an aqueous solution, okay, with zinc and copper. So the objective is to measure the electrodes, okay, to get energy, okay, voltage generated by this process. So before the study, we asked the research question: how it is possible to generate this electrochemical energy by reusing domestic grey water? So here the objective is determine the existing literature on electrochemical energy generation by reusing this domestic grey water, and design and build a prototype to generate electrochemical energy by reusing domestic grey water. So the objective is determine the electrical parameters also of the electrochemical energy generated by the reusing domestic water. So for this, construct this prototype was the design 6 replicas of number from 1 to to 7, okay, prototypes, in which was done a test that will carry on with one or more electrical measurements. So we have a number of experimental tests of 267 measurements carried out with these 7 prototypes structured as follows. 42 tests for each cell of each prototype every 5 minutes, on 70 tests for each prototype without loads of energy every 5 minutes, and 70 tests for each prototype with electrical charge, okay, every 2 minutes for this test, and using LEDs of different colors, qualifying the level of luminosity, taking into account that in the first level no light, and the second LED is low brightness, the third LED is medium brightness, and to get the high brightness with the 4 level of the LEDs. So the test was carried with an electrical load during 168 continuous hours, okay, of operation, and so the voltage were measured an interval of 2 hours for implementation of this prototype. Okay, was using a galvanic cell prototype made of cathode and separator electrodes. So the electrolytes will use this domestic residual water, and all of the above will be installed in the recycled plastic container from used batteries. Okay, so we can have here the plastic box constructed with recycled material from used batteries with 6 space conditioned on the galvanic cells to projected in the research. So was used these plates were the copper and galvanized iron plates to put inside this plastic box. Okay, and so we used also plate separators, okay, in the design of this prototype. So the dimensions that used of the copper galvanized iron electrodes was considered and was created in the plastic container with this preliminary design of the galvanic cell prototype will be inside the gray water, and so we have to test with the basic connection from the voltage to increase with the Kirchhoff voltage law, okay, for measure how is the behavior of this prototype with the galvanic cells and the copper cells. So here we have the plate separators used in the design of the prototypes, and here we have put inside the box, plastic box, okay, where we can test the energy. You can through here the gray water, domestic gray water, and we can measure with the electrodes for the generation of energy. So the result of the experiment was get some different voltage, okay. For example, in this test without charge in the prototype number 1, we have the cell number one, and no charge voltage was generated just 0.86 volts. Okay, so in each one of these tests, we get low voltage. But using the coefficient of determination of R squared of the polynomial equation, working with the water in this container prototype, we can observe that is an increase in of the current. And so using the different formulas equations in these 168 hours, we can get values of the voltage between more or less 5 volts with the maximum voltage of 5.32 and the minimum 5.10 voltage. Okay, so the median in 5.22 voltage. Okay, and standard deviation about 0.0626. And so the study successfully demonstrated that the potential of the domestic greywater as a source of electrochemical energy. So an special design prototype generated on average voltage of 5.19 volts. Okay, without load or charge, and proving they capable of powering low energy device. As we know, is a small battery, use a low voltage. Okay. Also, the charge of the mobile phone use low voltage to charge. Okay. So these are experiments that we are working in the lab, and so to increase the voltage. But the most important is that here is what used these domestic grey-waters that we can get energy. Okay, small energy, maybe working more or adding some special components, chemical components, we can increase the voltage. In the state of the art, is the maximum voltage using other types of water is almost 8 volts. Okay, here we are using just gray water. We do not find previous studies which can get these results. We know that the limited is no a high voltage, but it's good starting to continue researching for get energy. Okay, so thank you very much.
Thank you for the presentation, sir. Thank you for your fascinating research contribution also. Definitely it will leave positive impact on our planet. Thank you for that. Any queries from audience side?
Yes, I have one question, please. This prototype that you present, do you have a practical or a practical way that we have it in other countries in terms of climate change in other countries, or it's only for the country that you are doing this research?
No, I think it can be used for any part of the world. We need to go in advance in the future. What is the situation of the world in using water and generating energy? So one solution for generating energy was using the cells. Okay, the solar cells, for example, using natural in generating lower power, but it was used in that remote places where there is no energy, electricity, for example, where it's in the farm, for example, or poor towns that is far away from the city. Okay, that most of them are forgotten citizens. So all families use water. Also, and many of this water is going through the sink and is not taking advantage of the use. Okay, so the other studies use that has done use special water with some requirements. Now we are working with the water that is just simply without a treatment, okay, to generate energy. So because this is the low voltage, but this is a voltage that we can reuse, maybe, okay, doing more research, we can improve the prototype. Maybe we can working and collaborate with this and trying to get increase this value of voltage. It will be a very good for the community, for the society also.
Okay, thank you. But I have another question. Do you have any estimated cost for this prototype?
Well, in this previous prototype, we used recycled material. Okay, so the cost is very cheap, using just material that is not used, but that is common to continue. More or less, approximately cost we can, well, in dollars, for example, we can, for construct this prototype, I think no more than $50, for example, no more.
Oh, good, very good. Okay, it's very cheap actually.
Yeah, yes.
Okay, thank you, thank you.
Okay.
So, if anyone have any questions? Okay, so we can move on to the next paper with the ID number. I think it is 125.
Yes, it is.
Mr. Darius, Jonan, and Pedro, are you available for presenting your paper with the title of The Use of Venom Diagram as a Design Tool for Generating Urban Patterns in Architecture? Are you there?
I think there are no present. I will call them maybe. Okay, you can continue with the next one. I will keep in touch with them.
Okay, okay. So we'll go forward to the seventh paper for today, which the number ID is 217, with classification of physical violence actions using conventional neutral systems with transfer learning. Are you available? Postio, I think.
Yes, Mrs. Yes, Mrs. Good morning.
Yeah. Good morning, or good afternoon, or good evening, according to our time.
Good evening.
Good evening.
Deori.
So maybe you can start and proceed with the presentation.
Yes.
Okay.
A moment, please. You can see my screen?
Yes.
Good. My name is Jose Garcia.
Yes. Make it a full screen, please.
Pon en modo de presentación está en esquema.
Thank you for translation.
Yes,
F5, F5 para que puedas
okay.
poner.
Yeah, ahí.
No, tienes que ponerlo en pantalla completa, creo, porque estás haciendo en... Muestra tu pantalla completa, porque has puesto ventana, creo. Así no funciona.
Okay, okay. Now?
Yes, yes. Okay, it is presentable.
Okay.
Please proceed.
Okay, thank you very much. My exposition is classification of physical violence action using convolutional neural networks with traffic learning. My name is Jose Garcia, and my partner is Ciro Rodriguez. The table of contents, can we see abstract, introduction, related work, property design, results, and conclusions. We start with abstract. I read very fast. Violence in the world is the problem and creates impact that affects any developing country. It represents a system that today cannot be controlled by having different manifestations with high rates and crime and delinquency. Artificial intelligence use different innovative resources covering heat resource, traffic management, climate change, among others, in the framework of the Sustainable Development Goals, being application auction image processing throws convolutional neural networks. The research evaluates efficacy of classification violence actions such as strangulation, grappling, kicking, and pushing, based on pre-trained CNNs. Fewer dataset and simulate videos in early section was elaborated compressing 2,000 images distributed in 60% for training, 30% for validation, and 10% for testing. And second, the CNN model with G16, MobileNet, ResNet 15, and Section B3 were training by applying transfer learning subjected to 250 outputs and using the same hyperparameters. At the end, the performance result were compared where it was determined that the best performance is for MobileNet, obtain a precision rate of 72.53% and accuracy of 66%. Differential research and a reference for future real-time applications. And the next introduction, we're talking about in America and in Peru. In America, Pan American Health Organization in its website announced that each year at least 470,000 people in the world died from homicide. A very alarming figure, even worse in America, which the ones in the high homicide rate, which is 3 times more than the global average. Where almost 500 people had died for days as a result of interpersonal violence. It estimates that at least 1 in 3 women suffer physical or sexual violence for their partners. Furthermore, the violence rates in Latin America and the Caribbean generates a climate of uncertainty and security in the population, which a problem relates to the stability to the government in power. The poor economy that makes a good analysis difficult to the contrast among other factors associated. In Peru, through loud number, 30,364. This law is about stopping mutual violence against women and family members, where violence is classified to four types: physical and psychological, sexual, economic, and patrimonial. Meanwhile, the National the Institute of Statistics and Informatics, INEI of Peru, in its 2018 summary on crime and citizen security announced that the most violence case are psychological and physical violence. That's in 2017, 65.4% of women between 15 and 49 years old were raped or some points by their partners. Today, AI also makes it possible to streamline this process of recognizing violence actions with aim implementing automated early warning system and communication in a timely manner to the authorities' competence. Related work, we can see the table is summary and reference that use CNN model with Stanford learning. For example, the authors Akiba et al. In 2023. These authors use models in MobileNet, no? We know the model MobileNet use a dataset pre-training called ImageNet. This author proposed a model, a new model called CONS LSTN, with accuracy 91%. No, can we see others authors? We study more or less 8 authors. Can we see the table 1? No? Our study of state of the arts. Proposed design. We may have our data set in this stage of preparation of the collection. It was decided to develop our own data set, simulate violence action in urban areas, making various videos recording, taking into account behaviors of body, movements of grappling, kicking, pushing, and strangulation. The recording were made with different cell phone models with cameras of 12 megapixel resolution. The idea in the simulated sense that we can be captured from the videos, surveillance camera in the urban area following these recommendations. The C1 is placed on a stand and tripod at the downward inclination was 50 degrees. Place the C1 on the support vertically at the height of the 2 meters, and the rest section aired horizontally at a maximum for 4 meters. 2 video recording are made which simulates various actions for an average 10 minutes and with a maximum of 2 participants. In the scene of figure 2, we can see later the maximum distance between camera and a violence sound detection is 4 meters. Other recommendation is do not expose the camera to rainy condition and the make recognition difficult. Also do not capturing camera with crowds of people that obstruct wet can view. Use the wet system during daylight hours with low reflection of sunlight without much brightness. In total, 2,000 frames of image measuring 1,920 by 1,088 pixels were captured and selected using a LVC multiplier, so what, which were distributed in shown in table 2 and figure 1, the next one. And we can see the table 2 and figure 1 and distributions of selected image. We can see as regulation, graphing, quicking, pushing. In total, had 500 each one. In total is 2,000 image, no? The folders is distribute the following distribution in the dataset folders. Each one test, train, invalid, had a graphing, hitting, pushing, dysregulation, each one. We can see some examples, violence actions, strangulation, grabbing, kicking, and pushing, more or less. The next one, training CAM model with transfer learning. The selected CAM model with training with the dataset using a laptop with 16 gigabytes and RAM on target GeForce GTX 1660 Ti GPU with 8 gigabytes of memory through an Anaconda and Jupyter Notebook software. The data augmentation technique was applied before executing the training to obtain more variance on the dataset and help avoid overfitting problems. Likewise, transfer learning techniques was applied to each pre-training models to stocking advantage always weights acquired in the original training with ImageNet, no? Whereas lost network layer were adapted to solve the model about output one of the 4 classes of physical violence. The sequence of the less additional layer, which was considered for each model, is detailed in table 3. We can see a sequence of layer applied transfer learning, layer flattened, dense. We can see neurons 100 to 8 activation, ReLU, and the layer dense neurons 4 activation softmax. For training, the image input were resized to 224 by 224 pixel and 3-color channels RGB, which model was configured with the following characteristics and hyperparameters detailed in table 4. We can see the detail in table 4, hyperparameter for trained ACC models. We use epochs 150, batch size 16, hyperparameter loss, categorical cross entropy, and optimizer, the delta, and metric. The most important is accuracy. The hyperparameter used result from the evaluation of the best of the state of the art with the purposes standardizing for each model. However, they can be different, and there is the possibility, performance, and combination of dead values between them, which would be a reason to perform another research. The next stage of the research, the results obtained from the training, validation, and testing of the pre-training CAS are disclosed. At the end, an analysis of the most important metrics of performance indicator is carried all through comparative table. And the results, we can use a methodology more or less to execute the training session. Python coding code was applied using Keras library, which allowed to use obtain each model where its final layers were subjected to transfer learning techniques with hyperparameter mentioned above. At the end of each training, the loss and the accuracy was graph view were developed with the help of the upload libraries and SQL libraries to display the confusion metrics. The graphs obtained from the training and validation process are shown with respect to the loss and accuracy metrics, in addition to conclusion metrics of each pre-training models is shown. The BGG16 MobileNet, ResNet 15, and Station B3 models were executed, and their times were taken as another indication to take into account. We can see a graphics and the loss share, accuracy graph, confusion metrics, the BGG of MobileNet, more or less. We can see the same. There was net 50 and section B3. Each one had a loss chart, an accuracy graph, and a confusion matrix. Finally, in summary, we can the table 4 result of the CNS models performance metrics. Each classes, triangulation, graphing, kicking, and plugin, an average of each one. We can see the MobileNet is the most indicator important. Is 66% of accuracy. In conclusion, an investigation was carried out to compile full pre-training CNN models based on transfer learning techniques to classify basic action of physical violence in urban areas. These experimental results show that pre-training models for these types of violence with their own dataset provide significant advantage which help reduce computational costs and configuration hyperparameters. Likewise, from the result of the performance metric, this estimates that the MobileNet model presents better performance compared with its similar BG16, ResNet 15, and in section B3. However, it states a longer time to train. This way, because MobileNet is considered one of the most optimal models to perform in scenarios with little process capacity such a mobile device, where his convolutional layers are better fitted to extract session features from the animation. However, it's necessary to highlight that for feature words or more rows that the datasets should be generated and examined with CNN models for object detection through bounding box labeling such as YOLO, Thunder, Picodet, among others that also provide retraining weights with the purpose of increasing the values of the performance metrics, in addition to implementing a prototype and intelligent video surveillance system in real time to detect sense to physical violence and automatical issues and alarm. Thanks very much.
Thank you for the presentation. It was a quite interesting topic. From the audience, do you have any question? If not, we can proceed to the next paper, the number 299. Are you available? With
Yes, ma'am.
nanotechnology, yes, enhance AI algorithms for early cancer detections. You can start. You can present your work now.
Yes, thank you, ma'am. I hope my screen is visible, ma'am.
Still not. Yes, now, yes. It is presentable.
Yeah.
Nice.
So, very good evening, all. Myself, Dr. Chandrakant Kupne from Nutan Maharashtra Institute of Engineering and Technology, Pune. So, today I'm going to present my paper, which is Nanotechnology Enhanced AI Algorithm for Early Cancer Detection in Microfluidic Systems. My paper ID is 299. So, let's start with the presentation. So this is the outline of my presentation. First, we are having the introduction, why we need the contribution of nanotechnology or these machine learning techniques in the field of image processing, basically the cancer detection or the early stage cancer detection. Next, we have the need of study. Then why we are going with this? Accordingly, I have a literature review. According to the literature review, gaps finding is there. So four important gaps we have. Then the proposed methodology with the results. So let's start with the introduction. As we know that the cancer is the very what we can say the crucial stage of each and every life. So as the cancer continues to be one of the most challenging, it is a challenge in the healthcare. So the detection of the cancer should be done in the early stage, and we have the classification what the patient is getting when the cancer is detected in early stage, or what are the drawbacks if the cancer is not detected in the early stage, or it will be detected in the later on. So here we have the diagram. The diagram clearly suggests that if the cancer is detected in the early stage with the help of nano technology, or we can say with the help of machine learning algorithms, that is supervised algorithms, then we are getting the higher surface areas, better targeting capabilities for better identification of the cancer cells. So on the second hand, we have, if we are not going to detect it by using, or if we are going to detect the cancer by using the traditional anti-cancer treatments, then the obviously the results are not accurate, or the clarification will not get here. So here the two game-changing technologies we have, the combination of nanotechnology and artificial intelligence to detect the cancers with the help of images, with the help of information, whatever information is associated with the image and the uses. Then the nanotechnology and microfluidics are converging, which holds the great promise, as we know that the microfluidic systems, the platforms enables to analyze and detect the cancers. So biomarkers are detected with the help of microfluidic systems. So why we are going with this study? So as we know that whenever we are talking about the systems, or whenever we are talking about any the application, any algorithm which is going to deal with the medicals, so as the sensitivity and specificity are the important parameters here. So if you are getting the integration of nano materials for microfluidic systems, and if you are going to detect the sensitivity and specificity of cancer biomarkers, so we can get the better results here. Second thing is that so many treatments are required, so many testings are required, so patient may undergo with uncomfortable treatments or uncomfortable testings. So as we are going to do it digitally, then there is a possibility that this approach reduces the physical and emotional burden on the patients. Third important aspects we have, that is the combinations of nanotechnology and machine learning algorithms with artificial intelligence enabled algorithms to develop the treatment, the chart, or what we can say the personalized profile, unique molecular profile of individual patient, so that will help for the doctors to detect it and to just track it. And the last we have the microfluidic systems, as we know that it is integrated with the nanotechnology and AI-based algorithms or AI-based applications, so that the whatever resultant product we are getting, that product are more compact and portable for making the diagnostic system more clear. So by considering the need of study, the literature review is done. So 25 to 26 papers are referred here. I'm just going to highlight the the most important things or the most important what we can say the algorithms that we are going to implement or we are going to extract here. So the first method is suggested by the authors, that is magnetic nanoparticles. So if you are going to observe this method, the basic approach is introduced with the isolation of circulating tumor cells. So basically they are talking about the breast cancers, and the finding is that the improved capture efficiency for rare cancer cells. So as the detection of the rare cancer cells was done by the authors here, and while detecting the rare cancer cells, they have used the supervised machine learning algorithm. But the drawback is that limited to specific cancer type. So as we know that the limited with the known markers. So it is not possible to detect all cells, or we can say it is not possible to highlight all the markers, because they have used the supervised machine learning approach for detecting the cancer cells. So as we have the scope here, that the potential for early detection and metastatic cancers here by just improving the learning techniques, as we are talking about here, the supervised machine learning algorithms, that is convolutional neural networks, recurrent neural networks, and XGBoost, that is the third important algorithm we have for just classification of this, or to detecting the early stage cancers by using the images, by using the user information. So after just going through the literature review, okay, second, what from authors 23 that we got, that the data privacy and security, they are just talking about a cloud environment. If the data is going to shift from user space to cloud space, how the security is addressed here, that even though the biomedical information is going to transfer from user space to cloud space. So the addressing concerns related to handling sensitive medical information, again they are talking about the confidentiality, as the patient's reports are going to forward from one machine to another machine. So we can say that is from source to destination. So the finding is that the implementing robust data protection measures in the diagnostic system, as the same feature is provided by different cloud vendors. The AWS Azure is providing the same services. The limitation what authors got, that the data breaches and the privacy violations could undermine the trust of technology. So this is very important in the field of medical science, when the data is going to transfer over a distributed environment. So this, by considering these important issues, there is some gap identified. So as we know that with the help of nanotechnology and advanced machine learning based algorithm, we can detect or by taking the images as an input, we can detect the cancers, or we can detect the diseases, and that the same is communicated to the patients and the doctors, so that it will be helpful to detect it in early stage. And if we know that if we are going to detect the cancers in early stage, then there is a possibility that to save the patients. And the multidisciplinary areas have the potential to alter the start. So the co-op cancer research and treatment by increasing the specificity. So two parameters are considered here with respect to cancer biomarker detection. So specificity and sensitivity is taken into consideration, and these two parameters are contributing great in to get more accurate results. We are talking about the F1 scores. And the third point is talking about the future cancer care is expected to be more efficient, as we are having the information, as if you are going to detect it in early stage. So in future it will be helpful for the users to get the information or early stage detection of the cancers, so that the necessary treatments will be provided. So basically I am talking about the rural areas, where in India so many rural areas are there, so the doctors are not reaching, or even though patients are not getting the information about the diseases. And basically if you are talking about the women's, the breast cancer is the most important thing. Even 80% women are not getting the detection in early stage, so there is a possibility that they may die. So just by just taking care, just by looking towards as a technological student or technical person, this is just my small try. So this is the proposed methodology we have. The proposed methodology is talking about the 4 different stages we have. The first stage is talking about the data collection. So data collection is very important here. So data collection and pre-processing, as the raw data is provided to the system. So it is the first stage during which the necessary information about the patient and the necessary biological samples are gathered here. So here the most important thing is that the what information is taken into consideration. So images are taken into consideration. So body fluids, tissues are completely categorized here from from the pre-processing. So the pre-processing is crucial to ensure the high quality data, and we are getting the exact, or what we can say, the after pre-processing or after data collection, we are getting the accurate data. Then the same is provided to the nanotechnology integration. The obvious question is that what it does, the nanotechnology integration. So nanotechnology integration is the crucial to improve just sensitivity and cancer biomarker detection. So as the complete process is talking about the cancer biomarker detection, this is taken care by nanotechnology. And once we are getting it, then the segmentation will be done, the feature extraction will be done, and from that available feature, the feature vectors will be constructed, and same will be used by using machine learning algorithms for training and testing. So after that, once we are getting the segment, as the segment is playing important role here. So what is segmentation? As we know that we are not interested in the complete image, the contour is considered, and from that contour the feature are extracted. So that we are talking about the stage number 3, that is the microfluidic sample processing. So once we are having the segment, once we are having the contour, that contour is taken into consideration here. So the samples included with nanotechnology can be processed quickly and precisely using microfluidic systems. So this makes excellent samples manipulation control. So the same is represented. The same information is represented by using biological samples, and the features are extracted from the biological samples. Once we are having the features, the last stage, that is stage number 4, is talking about the AI deep learning model, and we have the implementation. So this is the methodology, proposed methodology. So now we are going to discuss how these 4 stages are categorized into different steps with respect to 3 machine learning algorithms we have, that is the convolutional neural networks, recurrent neural networks, and XGBoost. As we know that CNN is basically talking about the images, so data pre-processing is done here. So images are taken into consideration here, and the convolutional neural network is having one of the feature is that it having the feature extraction and segmentation which is combined here. So in convolutional neural networks, which is used for analyzing pictures, basically it talks about the X-rays what we have for a diagnosis process. The primary purpose of CNN is to extract the and classify features from images. So as whatever stages we have to get the image, to segment, to perform the segmentation, then the feature extraction. So pooling layer is here, which is performed with the max function. Then the flattering, fully connected layers we have, which is represented by using y is equals to function of wx plus p. So where the y is nothing but the output of the fully connected layers, we have the x with the flattered feature vectors. W is nothing but the weight matrix. So initially the randomly initialized weight matrix is taken into consideration. So the same will be provided with the output layer. Then we have the training, evaluation. So here the most important thing is that the evaluation of CNN model is done by using validation and test data sets. So whenever we are talking about the data sets, obvious question is that what data set we are using for training and testing. So we are having Viscoine's diagnostic breast cancer data sets. So this data set is already freely available. The data set is used for the training and testing purpose. And at the end we are having prediction model. So the train model we are getting with CNN. So here the most important thing is that images are processed with the CNNs. Next, we are having RNN model. As we know that RNN model is by default comes with LSTM, that is large small term memory. So obvious question is that what information is going to process with RNN. So here the patient records. So what we have, the sequential data, we have the patient record we have, which is available in the text format, that is processed with recurrent neural network model, that is the RNN with LSTM. So whatever patient records we have, it will be taken into consideration. Again, the pre-processing will be done. So as we are talking about the RNN model, the pre-processing is sentence splitting, tokenization. Then POS tracking will be done with stemming lemmatization. After that, the model comes. That is, the important keywords are fetched from the patient records, which will be considered for the training purpose, which will be considered for the testing purpose. Accordingly, whatever keywords we are getting, that keywords will be represented, and same will be used for the training and testing. Same will be represented with the help of word embeddings. So model, whenever we are talking about the stage 2, the RNN model recurrent layers need to initialize. So we are having the feature vectors, or we are having the word vectors here. Standing is going. So third, we have the algorithm third, that is the XGBoost. So as we know that the XGBoost is the robust machine learning algorithm that can help us to understand our data, and it is basically talking about the decisions. and how the decisions will be taken care. So it is just representing or XGBoost is implementation of gradient boosting decision tree, and based on that decision tree, so the classification will be done. So here we have the pre-processing. The data sets are taken into consideration here. So we are having the data pre-processing task like removing duplicate records. So that will be taken here in the pre-processing. Next we are having initialization of XGBoost model. The boosting parameters are initialized here. Then we are talking about the training. So use gradient boosting to train. As I rightly said, it is constructing the tree, decision tree for classification purpose. Then the prediction evaluation is done by just determining how well the XGBoost model is performing in AUC ROC. As we know that AUC ROC, that is ROC, it is the score area under the ROC curve, and it is used to identify how your results are better. It is just a unit which is same as the F1 score. So after just having the stages here, the evaluation and validation we have. So how the results are validated, how the data sets are validated. So data set is validated by using
I'm
so
so sorry to interrupt you, Doctor, but we already passed our time for the session by 5 minutes already. So could you please just go through your conclusions and results? Yes,
yeah.
as quick as you can, please. Thank you.
Yes,
I'm
ma'am.
sorry again.
Yes, thank you, ma'am. So here we are having the results. So results are compared by using three machine learning algorithms, supervised machine learning algorithms with a CNN, RNN, and XGBoost. So if you are talking about the accuracy, so the CNN is giving us the highest accuracy, 96.33%. RNN with LSTM is having 92.56%, whereas XGBoost is having 94.50%. The same information is represented in the graph with the help of accuracy, sensitivity, specificity, precision, F1 score, and AOC ROC, that is the area we have. So that talk about how effectively results we are getting. So if we are talking about the sensitivity, so the RNN is again generating 94.52% of sensitivity. CNN, RNN is having 90.66% of sensitivity, and XGBoost is having 92.45%. So here, if we are going to consider the F1 score, as it is ranging from 0 to 1, so on the scale of 0 to 1, we are getting 93.41% of F1 score, and by RNN we are getting it 90.20, and XGBoost is having 92.49. So by considering this F1 scores and AUC RUC score, then the CNN is performing well as the machine learning algorithm for detecting the early stage detection, as it is done with the help of images. So next we are having two different graphs. They are talking about the accuracy, and again the CNN is having so near about 95% of accuracy, and the second figure 5 is having the comparison of evaluation parameters with respect to deep learning models. So again, if we are going to observe here the accuracy, sensitivity, specificity, precision, F1 score, then again CNN is having good results in the field of detecting the images, taking the images as an input, and detection of the early stage. So last we are talking about the conclusions. So here, if we are going to discuss, as I rightly said, that the CNN is generating good results. So with the 96.33% of accuracy we are getting. So here, as if you are going to compare the performance or impressive performance with AOC ROC, against CNN is performing well by using the dataset, that is WSBC. Then XGBoost, a gradient boosting algorithm. So it is just used, or if you are going to observe the results of XGBoost, so the accuracy is 94.50%, and the region, the interested region, or the AUC RUC score is 96.23. So after analyzing all the implementation details, after analyzing all the contributions, after analyzing all the stages, that is including pre-processing, segmentation, and feature extraction, the CNN algorithm is performing well in the field of this biomedical field by taking images as inputs. So these are the some important references we have, and thank you. Over to you, ma'am, if you have any questions. Should I stop sharing, ma'am?
Yeah, you can stop sharing. Any query from audience side? I guess no query. Thank you for the presentation.
Thank you. Thank you very much for your presentation.
So the next ID, Dr. Mass, it is, I think the left one is 125. Paper ID
125.
125.
Yes, yes, yes.
It
This
was
is
left.
the only one that we have left for our session.
Yeah.
It is number 6 by Darius, the author Darius and Pedro. Are you available for presenting the paper?
Good morning, everyone.
Yeah, good morning, good afternoon. Uh, if you want to start sharing your slides.
Can you see the presentation?
Yes, yes. So, presentable. Thank you. You can start now.
Okay, this is I use the Werner diagram as design tool for generating urban patterns in architecture. For the introduction, we have importance of urban design, pattern design, exploration urban pattern topologies. For the methodology approach. For the results, study location and terrain analysis. If efficiency and psychology compensation. For the conclusions, innovating urban design approach, optimize circulation and mobility. In the abstract, urban design plays a crucial role shaping the functionality and livability for the cities. This paper explores the utilization for the Voronoi diagram as innovating design tool for generating urban layouts in architecture. The research aims to investigate how the Voronoi diagram can be employed to produce efficient for tailored urban designs that cater to specific needs for communities. The introduction highlights the significance of urban layout design in cities deployment and discuss various typologies used historically. Additionally, it introduced Grasshopper, a parametric design algorithm, model implying integrated with Rhinoceros software as a powerful tool for generating complex geometry in urban design. The paper delves into Voronoi diagram as mathematical technique urban planning, emphasizing its benefits in optimized spatial distribution for elements such as transportation, infrastructure, and public spaces. The study employs software tools like Rhinoceros and Grasshopper, along with geospatial and demographic data to analyze the project location and define design criteria. The results section highlights a specific study location in Girón Las Uvas, Santiago de Surco, detailing the characteristics of divided terrain and diagram-based designs compliance with building regulation. Furthermore, the conclusions underscored in the innovation potential of Voronoi diagram in urban design, particularly in the enhanced circulation efficiencies and improving the residence quality of life through optimized mobility and connectivity. Overall, this paper contributes advancing understanding and application of computational design methodologies in urban planning and architecture. Introduction. Urban design stands as cornerstone in deployment and functionality of cities worldwide. Its influences extends beyond mere aesthetics, profoundly shaping the way communities interact with their environment. As cities evolve and expand, the need of innovation urban layout design methodologies becomes increasingly apparent. This paper explores such as methodology, the utilization of Voronoi diagrams as potent tool generation urban layout with architecture practice. As a critical aspect for this exploration lies in contextualizing the significance of urban layouts design through history, from ancient settlements to modern metropolises, and a range of streets, buildings, and public spaces reflects not only practical consideration but also cultural, social, and economy dynamics. Traditional layout topologies such as dense and irregular layouts, grid patterns, radial designs, and organic configuration have each laid their mark on urban landscapes. The research core objectives is to develop into the applicability of Voronoi diagram in creating urban designs that are both efficiency and customized to meet the unique requirement of diverse communities by embracing computational design techniques, particularly those enabled by tools like Grasshopper integrated with Rhinoceros. Software architects can unlock new dimensions of creativity and functionality in urban planning. In recent decades, the emergence computational tools has revolutionized architecture practice, offering architects and present can be tonalized to interact and optimize design among these tools. The Voronoi diagram has generated attention for its potential in inform spatial organization urban contexts. This paper seeks to explore the theoretical foundations, methodological approaches, and practical implications of delivering the Voronoi diagram in design tool in contemporary urban architecture. Methodology. This study employs a multi-phase methodology aimed to explore the application of Voronoi diagram in the urban design. The research methodology in several case stages. Each design contributes through understanding of subject matter to and facilitate the generation of value insights. For data collection analysis, the first phase involves the collection analysis of geospatial, demographic, and socioeconomic data pertaining to the study area. By gathering the related to land use, pollution distribution, infrastructure, and other relevant factors, researchers gain value insight to the urban existing context and identify parameters that influence design decisions. For the software utilization, the study leverages advanced computational tools such as Rhinoceros and Grasshopper to facilitate the generation and manipulation of complex geometries. This parametric design and algorithmic modeling platforms empower architects to explore a wide range of design possibilities that rapidly iterate on concepts and evaluate design performance against predefined criteria. Through the utilization of these software tools, the research aims to demonstrate the practically, feasibility, and effectiveness of integrating Voronoi diagram into the urban design process. For the results, the study area selection, the study area chosen for investigation is Girón Las Uvas, situated in Santiago de Surco. This location was likely selected due its deserved urban characteristics, to make a suitable for examining the effectiveness, which make it in of Voronoi diagrams based urban design solutions. By focusing a specific area, research can analyze the impact of Voronoi-based interventions of existing urban conditions and assess their potential for improving spatial organization and functionality. The characteristics of the study area. This subsection develops into the unique attributes of Girón Las Uvas, providing insights into topography, infrastructure, and land use. Understanding these factors is crucial for devising urban design strategies that address the area's specific changes and opportunities. For instance, note topographical variations can inform decisions regarding building placement and site development, while the insights into existing infrastructure Network can be guide proposals for engage connectivity, and accessibility. Compliance with building regulations, a key consideration in urban design projects in adherence to building regulation and zoning orderings. This subject highlights the compatibility of Venn diagram design with national building codes, indicating that such as approaches can be meet regulatory requirements while still achieving the desired design outcomes. By demonstration compliance with legal frameworks, researchers validate the feasibility and practicality of Borno-based urban interventions, paving the way for the potential in implementation in real-world contexts. Practical viability, the result suggests the Borno diagram based for urban design solutions exhibit practical viability, meaning that they are feasible and applicable within the constraints of existing urban governance structures and regulatory frameworks. This finding is significantly as it demonstrates that environment-based approaches are not merely theoretically constructs but have tangible uh, applications for urban planning and development. By the emphasizing the practicality of Borno-based interventions, research underscored their potential address real-world urban change and improve the quality of urban life. Implications for the urban design practice. The insights generated for the study have broad implications for urban design practice, certainly new possibilities and innovative design approaches that prioritize efficiency, adaptability, and community responsiveness. By the showcasing the benefits of Venn diagram-based techniques, research advocate for the integration into mainstream urban design methodologies, potentially reshaping the way cities and planning build and experiences. For the future research directions, building on the findings of this study, future research directions are proposed to the further explore the application of random diagrams in urban design and planning. This may include investigations into different scaling levels, comparative studies with other design methodologies, and examining of social cultural factors influencing design preferences and outcomes. By dilating for future research pathways, researchers aim to catalyze ongoing discourse and innovation in the field of urban design theory and practice. Burnout rate, circulation line lengths, and travel times. This table presents the length of circulation lines with the burnout-based urban layout, along with the minimum and maximum travel times to record for each line. The data demonstrate variations in travel time based on length. The lines provide insights into the route planning and urban mobility optimization. Line lengths. The line lengths of circulation lines indicate the physical distance traversed within the border-based urban layout and the minimum and maximum travel times. The recall travel times represent the range of time taken to traverse each circulation lane, reflecting the variations in traffic flow, in congestion, and road efficiency. Grid layout, circulation light length, and travel times. This table presents the similar data to table 1, but for the grid-based urban layout includes circulation line length and corresponding the minimum and the maximum travel times, allowing for comparison with burner-based layout in terms of circulation efficiency. Line length, similar to table 1, the length of circulation lines within the grid layout indicate the physical distance traversed within the urban fabric. Minimum travel times. The record travel times in Table 2 represent the range of time taken to travel each circulation line within the grid layout, providing insight into the road efficiencies, congestion travels levels. Circulation efficiencies. The primary focus of this study was to compare the circulation efficiencies of two different urban layout topologies, the Voronoi-based layout and the grid layout. The results clearly indicate that the Voronoi-based layout generally exhibits lower travel times compared to the grid layout. This suggests that Voronoi-based approach offers advantages in terms of optimizing urban mobility and reducing congestion. For the factors influencing circulation efficiencies, several factors contribute to observe different circulation efficiency between the two layout topology. The Voronoi-based layout, characterized by its organic adaptability and flexibility, spatial distribution, allows more direct and efficient circulation routes. In construct, the grid layout with rigid and unified structure often necessarily longer travel distance due to the constraint following of perfect grid lines. Urban design considerations. The findings of the study have important implications for urban design practice and city planners by highlighting the benefits adopting Bruno-based design strategies. The study underscored the importance of consideration, innovation, and adaptable approaches to urban layout design, integrating possibility of flexibility and organic spatial distribution can lead to more efficient level urban environments. Limitations. For the conclusions, we have a limitation and future directions. It's essential the limitations of study and identifies for areas for future research, while the comparison between the Borno-based layout and the grid layout provides the valuable insights. Further investigation could explore additional factors influencing circulation efficiency, such as additional factors, land use patterns, transportations, infrastructure, and socioeconomic dynamics. Additionally, conducting comparative studies in different urban contexts could enhance our understanding of applicability and effectiveness of Voronoi-based design principles. For the practical implications, the finding of this study have practical implications for urban planners and designers by demonstrating advantages of Voronoi-based design in terms of circulation efficiency. The study encourages the option of more flexibility and adaptive design approaches, even Voronoi-based principles in real-world urban projects could lead to enhanced mobility, reduce congestions, and improve the quality of life for urban residents. In conclusion, the discuss highlights the significance of the study's findings and advantages, our understanding of urban layout design and its impact on circulation efficiencies by emphasizing the benefits of Voronoi-based design strategies. To the study contributes the discourse on innovating approaches to urban planning and design, moving forward to further research and practical applications of Voronoi-based principles can be continued to shape more the sustainable efficiencies lively great cities. Thank you.
Thank you very much. It was very interesting presentation. From the audience, do you have any questions? Any inquiries? Okay. Thank you very much. It was a very successful session. Thank you everyone for your participating. Dr. GREESHAMA, do you have any comments?
No, thank you, Dr. Mais. It was really a great session, and thank you for sharing this platform with me. I wish you good luck for future.
Me too. Thank you very much. Thank you all. We will finish this session. Maybe we can join the session which is already started in the link that Dr. Ashish sent us. Thank you for having us and thank you for your insights. And we are looking forward to see you again maybe next year. So thank you. Bye bye.
Thank you so much, the respected session chairs and all the paper presenters for making this session a successful one. Thank you so much.